Hi, I'm Cheryl Leach. In this problem, we're going to be using Newton's method to help us find the x-coordinate of the intersection point of two functions. The first one being 2x plus 1, and the second one, the square root of x plus 4. Now we want our answer to be accurate to 3 decimal places. All right, well the first question I have is Newton's method is used to find roots, or x-intercepts. But that's not what this question is asking. I'm looking for the intersection point. How can I use Newton's method to help me answer this question? Well, how do you find an intersection point? You want to find the place where these two functions are equal to each other. So let's go ahead and do that. Let's set 2x plus 1 equal to the square root of x plus 4. Now, how would you solve that equation? Well, we're going to move the root over to the left-hand side so that I have it set equal to 0. So I'm going to write this as 2x plus 1 minus the square root of x plus 4 equals 0. And now what's happened? Well, I've transformed my question into finding when is this expression equal to 0. In other words, I want to find the root of that function. So I've created a brand new function for myself. The function I've created, I'm going to call h. And it's 2x plus 1 minus the square root of x plus 4. And I want to find the root of this function. Okay, well, it's time for Newton's method. Now if you notice, I already have our table filled out. So I'm going to go through and explain where I get all of these pieces. But before I do that, notice that when I use Newton's method, I need the derivative of the function I'm working with. And I don't have that yet. So let's go ahead and take the derivative of my function h. So h prime is going to be the derivative. The derivative of 2x is 2. The derivative of 1 is 0. And I'm going to have minus the derivative of this radical. Now remember, you can think of the square root as having an exponent of 1/2. So I'll have a 1/2, which I'll bring down, copy over the x plus 4, and subtract 1 from the exponent. And that gives me my derivative. So if you want to, you could write this as 2 minus 1 all over 2 times the square root of x plus 4. Now I have all the pieces that I need to do Newton's method. Okay, so I need to begin with a guess. And in this particular case, I'm going to start with a guess of 0.5. Because if I look at my graph, now remember this one shows the intersection point, it looks like it's intersecting when x is about 0.5. So 0.5 is going to be my guess for the solution to my equation. So then I want to plug 0.5 into my function h. So I'll take 0.5, multiply it by 2, add 1, subtract root 0.5 plus 4. And that will give me this value. Next, I want to evaluate h prime at 0.5. So again, I'm going to plug 0.5 into my derivative. 2 minus 1 over 2 times the square root of 0.5 plus 4. And I get 1.7643. Next step is to get the ratio. So I'm going to take this number divided by this one. And that gives me my ratio. Finally, I will take 0.5 minus my ratio. And remember, this is the rule for Newton's method. It might look a little different because I'm using h's, but that's because the function that I'm using, I have named h. All right, so I've gone through my first iteration, and remember what you do. You take your final answer, and it becomes your next guess. Then you start the process all over again. But before we do that, let's just double check this. Am I close enough? I said I wanted to be accurate to 3 decimal places. Well, these two are farther apart than that, so I'm going to keep going. So I fill out my entire table, and I come up with 0.56873, and it becomes my new guess. All right, I can go through the process again, but before I do, let's take a look at these two numbers, 0.56876 and 0.56873. They're definitely within the 3 decimal point tolerance that I'm looking for. So the x-coordinate to this point is going to be approximately 0.56873. If you wanted to find the y-coordinate, You just have to plug it into either one of those and do the calculation. I hope that helps. Thanks.